So this build I just finished yesterday. This is my new Dr. Octature in 5U format. It's a little different than the IntelliGel unit. It's got a three input mixer for one thing, so you can mix 3 inputs. Those gray knobs on the left, and then it's got a mix out knob, so you can adjust the 3 inputs to whatever levels you like, and then you can turn the whole thing up or down with the mix out. And above about 50% on the mix out, it clips. It's got Zener clippers, back-to-back Zeners on the input circuit, and they start to clip the input to give you a bit of warmth. And there's a little clip LED next to that bottom gray knob, which will light up when it starts to clip. This one has coarse and fine frequency controls, which are the blue knobs. It's got a resonance and voltage controlled resonance, which is the green knobs. And then it's got 2 FM inputs. One monopolar FM input, which is FM1, and the other is a bipolar input, FM2. And then it's got a couple of switches. It's got a range switch. This can be you can run this in VCF or LFO mode. It actually goes down to quite slow speeds in VCF mode, but as an LFO, you get more stable, robust sine waves in LFO mode. And it's got quad and mono. And what mono is when the switch is in the mono position, this filter is set up like a standard 4-pole Roland filter. And what that means is when you are at high resonance, you'll start to lose the signal a little bit because the resonance tends to overwhelm the signal in Roland filters. But in quad mode, what that does is it engages extra circuitry, which distributes the resonance gain across all 4 channels. In a typical Roland filter, all the resonance gain is in channel 4, which is recycled back to channel 1. And when the resonance gain gets up to a total of 4, the filter starts to self-oscillate, which means that the first three of the 4 filters are at unity gain, fixed at unity gain, and only the 4th filter stage does the resonance by going up to a gain of 4. What I've done in quad mode is I've put gain amplifiers on each of the 4 stages, so that when you have a loop gain of 4, each of the 4 stages is at a gain of square root of 2, 1.414, outly. And what that does is it gives a bit of what you might think of as bass boost, or it makes each of the outputs more robust than it would have been. And it also ensures that the sine waves coming out during self-oscillation are all of equal magnitude. They're all plus minus 5 volt sine waves, basically. I wanted to show you the build. This is my new standard for building, with the panel board, this translator board, and the circuit board. And this also has panel wiring in terms of the jacks, but again, when I've ordered some jacks with PCB tabs, and when those come, I will change this and eliminate all that panel wiring. It's also quite nice. Those PCB mountable jacks will be quite nice because it'll allow me to also PCB mount the 8 LEDs that are associated with those 8 output jacks. But this was a very easy build. It worked the first time. Actually, it didn't work the first time because I had a dodgy chip. One of these 2164 chips was a dud, but I replaced it and everything worked perfectly. So I'm going to put it back in the case and show you how it sounds. Okay, I've got it back in the case. I'm just going to play a bit of stuff to demonstrate how this thing sounds. I've got 2 VCOs hooked up to it. Let's not think about this 3rd VCO because it doesn't have any keyboard control. So I've got 2 VCOs hooked up to 2 of the inputs. We'll just listen to VCO number 1. So the first thing I'm going to do is demonstrate it in mono mode. So this would be like, so I've taken the quad mono switch down to mono. So this will be like a standard Roland filter. I have to turn it up because it's so soft. So you can hear the whistling of the resonance, and the signal is kind of weak. Now if I turn on the quad mode, now listen to the signal. All right, now let's see. What if I turn on some FM1 here? Turn that up a little bit. Now let's turn up the second voice. Maybe a little loud. Now what happens if I put 1 volt per octave? I turn off that second voice. And what happens if I put 1 volt per octave in the filter? Turn off that FM. Turn it up a little bit. Turn down the resonance a little bit. So if I take off the 1 volt per octave, anyway, it's a great little filter. It's always been my favorite. Turn the resonance down. A little less attack. Bit of resonance. Anyway, you get the idea. If you want one of these, I'm selling these. Haven't quite decided on a price yet, but send me a message or message me on Muffs as Dr. Sketchy or whatever, and I'll set you up with one. I'm building these. I'm happy to build these right away. Okay, cheerio. So here's the filter without keyboard control. And here's the same settings, but with 1 volt per octave keyboard control. So I've got a reverse envelope coming in. I turn the envelope to positive, turn the frequency down a bit. Bit more. Take off the attack, bit more decay. But then I'll give it some attack, a little less decay, set the FM control to negative, turn the frequency up. With keyboard control, that's pretty cool. Without keyboard control, it's also cool but different. That's and I put keyboard control back in. So it's very important to have bipolar FM controls on a filter, as far as I'm concerned. It's also very important to have 1 volt per octave control, or the option of having 1 volt per octave control. Now, if you don't want full 1 volt per octave control, you can plug the keyboard control into FM1 And then use the FM1 knob to give you control over how much keyboard control you have. There's no keyboard control. There's half keyboard control. And there's full keyboard control. Anyway, very versatile filter.